This video is going to be about similar shapes, that is enlargements or reductions, and it concerns areas and volumes. So here's a little rectangle, doubled its length, doubled its breadth. So the scale factor for length is 2. In area though, it's got area 4. So the area scale factor is 4. Twice the length, twice the breadth gave us area 4. Here, the little rectangle has been 3 times in length, 3 times in breadth. So the length scale factor is 3, but the area scale factor is 9. 3 times the length, 3 times the breadth gives you 9. There are 9 boxes there. Here it's 4 times as long, 4 times as broad. Length scale factor is 4, but there are 16 little boxes in there. So the area scale factor is 16. That's 4 times the length, 4 times the breadth. 4 4s are 16, 3 3s are 9, 2 2s are 4. So that's areas. Square the length scale factor. Here's another shape. Triangle. Double its sides. Twice as long, twice as high. 4 times in area. 3 times as long, 3 times as high, 9 times in area. 4 times as long, 4 times as high, 16 times in area. So that's area scale factor, square the length scale factor. Supposing we took this shape and scaled it up to this shape. So this is side 2 and that's side 3. The length scale factor is image of the original, 3 over 2. But notice the area scale factor is the 9 over the 4. So the area scale factor, 9 over 4, came from this. We scaled the length by 3 over 2, we scaled the breadth by 3 over 2. So overall, 3 over 2 got squared to be 9 over 4. 3 3s, 2 2s. General rule, if you've got the length scale factor, square it, multiply it by itself, and it'll give you the area scale factor. There's the rule. Now we apply it. This little star has been scaled up to the big star. The 12 height gets scaled up to 15, but what happened to the area? What did 48 become? We're trying to work out A. That's there for the image. Scale factor is image over original. For lengths, it's 15 over 12. That simplifies to 5 over 4. Top divided by 3, bottom divided by 3. It's top heavy, so it's an enlargement. That's an improper fraction. Area scale factor, square the length scale factor, 5 5s, 4 4s. Now you scale the area. 48 gets multiplied by the scale factor to give you the new area. So to get A, multiply 48 by 25 over 16, divide by the bottom number 16 and multiply by the top number 25. 48 divided by 16 is 3 times 25 is 75. That's 75 square centimetres. So it's length scale factor, square it and apply. Here's another example. Cost of glass can be assumed to depend on the area. So this cost £100 because of its area. What would this one cost? It's been scaled down. 1.5 has gone down to 1.2. So B is the image. Scale factor, image over original. Length scale factor, image 1.2 over original 1.5. 1.2 divided by 1.5. Without a calculator, you can make that 10 times bigger in the top, 10 times bigger in the bottom. It's 12 over 15. And 12 and 15 will both divide by 3 to give you 4 over 5. So that cancels down, simplifies to 4/5. That's the length scale factor, square it. That's the area scale factor, 4 4s, 5 5s. Now scale the money. £100 gets scaled down to find B. So take £100, multiply by 16/25, the area scale factor, divide 25 into 100 and times by 16. 25 into 100 is 4, times 16 64. That was £64. So that's area scale factors. Square the length scale factor. Volumes. If you take this little box and you want to double up its sides, twice as long, twice as broad, and twice as high. Now what happened there was it was 2 times the length, 2 times the breadth, 2 times the height. There's now 8 boxes there. So that's the volume scale factor, 8. Length scale factor was 2. 2 times 2 times 2 gave us 8. So we want to make it 3 times as long. 3 times as long, 3 times as broad. That's now 9 in the bottom layer. And 3 times as high, we need to add on another 2 layers like that. Another 2 lots of 9. So that was 3 times as long, 3 times as broad, 3 times as high. That gives you 27, 3 times 3 times 3. So, volume scale factor is the cube of the length scale factor. Now consider this case, this cuboid, side 2 is scaled up to be side 3. So 2 lengths, 3 lengths. Volume scale factor is the cube of the length scale factor. 3 over 2 for the length, 27 over 8 for the volume. Here it is here. 3D shape has length, breadth and height. Scale factor 3 over 2 for the length, for the breadth and for the height. 3 over 2 times 3 over 2 times 3 over 2 gives you 27 over 8. 3 times 3 times 3 in the top, 2 times 2 times 2 in the bottom. Here's the general rule. Length scale factor A over B, cube it to get the volume scale factor. And there it is summarised. So length scale factor, cube it, multiply it by itself and itself again. Here's how to apply it. This little jug, we want to know its volume. This big jug has been reduced to this small jug. They are similar. A is the one we want to calculate. That's the image. Length scale factor, image over original. 12 goes over the 15. That simplifies to 4/5. Volume scale factor, cube that. 4 times 4 times 4 is 64. 5 times 5 times 5 times 5 is 125. Now scale the volume, 250. Multiply by the scale factor for volume and you'll get A. 250 gets divided by 125 and multiplied by 64. 250 divided by 125 is 2 times 64 is 128. That's 128 ml. So that's the volume scale factor. Get the length scale factor, cube it, and then apply the volume scale factor. Here's another example. You can assume the cost of the bleach depends on the volume of the bleach. So here we want to work out the cost of this bleach, B, so that's the image. For lengths, put the image over the original, so that's 15 over 12. That cancels down to 5 over 4. That is, it's an enlargement. It's a top heavier improper fraction, so the answer is going to be bigger. That's a length scale factor. Cube it, and you've got the volume scale factor. 5 times 5 times 5 is 125. 4 times 4 times 4 is 64. Now, that's the volume scale factor. The money depends on the volume, so scale the money using the volume scale factor. That's £3.20. 3.2 times 125 and divide by 64. So that's what you have to calculate. It's possible to do that without a calculator if you spot that 32 goes into 64. So 32 goes into 64 20 times. So that's like 1/20th. You could divide 125 by 20, or you can use a calculator there. It's 6.25. That's £6.25. So that's the volume scale factor. So we've done area scale factors, volume scale factors, and if you use a link, download this booklet using the link, and you will find in there an exercise on area, followed by an exercise on volume, and at the very end, answers to the area and volume. It's possible to do these without a calculator, though some of them can be very tricky. So, as well as that, from the same link, you can download a set of notes for all the videos on similarity, and it covers area and volume with examples. The next video will be on working area and volume scale factors backwards to the length scale factor. Hope you found this video useful. Thank you.